Let's practice writing expressions to represent the area of a sector as well as an arc length of a particular sector. All right, so I'm going to go ahead and start with the area. We're going to be finding the area of the sector that is shaded over here. That's going to be this entire piece right over here. So it's going to be most of the area of the circle. Now, what I'm going to go ahead and do is write down the formula. So the area of a circle we know is going to be pi times the radius squared, or pi r squared. In this particular problem, we know that the radius is going to be represented by this variable x, so we can't actually find the area, but we can write an expression that represents it. So again, we do know that the r value in this particular circle is going to be x. So if we want to say the area of this entire circle, the area of the whole thing is going to be pi times this x squared. That's going to be the area of the entire circle. Next, notice that the central angle that we don't want is 60 degrees. So what's the central angle of what we do want? Well, it's going to be 360 minus 60. So this is going to be 300 degrees in terms of the central angle of what we want. Now there's a few different ways that you could go ahead and write an expression to represent the area here, but I like to go ahead and set up proportions here. So here's what I'm going to set up. Basically, I like to set up this part to whole and part to whole ratio and write a proportion to go ahead and solve this. So here's how I'm going to do here. The part is this 300 degrees. We know we have 300 degrees out of how many degrees? Well, the full circle is 360. So that's the whole thing. So we know we want 300 out of the 360 degrees. And then what about the area of the sector? Well, the area here, we know the whole area is going to be this pi x squared, right? That's the entire thing. Pi x squared. And what are we looking for? Well, we're looking for the area of just the sector. Now, I'm going to go ahead and maybe use the variable of y here to represent the area of that sector. So let's go ahead and simplify this ratio over here on the left. If you go ahead and divide top and bottom both by 60, we're going to get a ratio of 5 to 6. And this is going to be equal to this ratio of the area of the sector we want to this pi x squared. All right, next what we can do is just maybe use a little bit of cross multiplication here. So if we go ahead and use cross products, we can say that 6 multiplied by y would be equal to this 5 times pi x squared. So let's go ahead and just write that down, 5 pi x squared. And then finally, if you go ahead and divide both sides by 6 here, we can find out that y, or the area of that sector, is going to be equal to 5 over 6. And this is going to be pi x squared. And so even though we don't know what the radius is, this expression of 5, 6 pi x squared would represent the area of that shaded region over there. If we knew the value for x or the radius, we could plug it in and you would find the area of that gray region. All right, now that we have the area, let's maybe go ahead and see if we can find out the arc length of what we have over here. So when we say find the arc length of this sector, we're really just talking about the part of the circumference here, right? It's going to be from here all the way around here. So we're going to see the length of this arc, which is going to be part of the circumference. All right, so let's go ahead and see if we can find this arc length. Let's go ahead and let z represent this arc length, and let's go ahead and solve for it. It's important to remember that when we're thinking about arc length, that we're also thinking about the circumference because they're related. So circumference is going to be 2 times pi times r. That's basically the longest arc length. It's all the way around the circle. And so any other arc length that we have that's not the entire circumference is just part of that entire thing here. So in this particular case, again, we know that the radius is represented by x. So if we want to write this circumference formula in terms of x here, it's going to be, let's see, 2 times pi times x. Now, just like earlier, I'm going to go ahead and use this whole part to whole and part to whole relationship. This is really nice, again, just because we know that entirely around the sector part, we know that we have 300 degrees out of 360 degrees. So what's nice is you can just go ahead and use this again. And on the other side, what are we dealing with here? Well, we have the entire circumference, which we know is going to be 2 pi x. That's all the way around for the circumference. And what are we looking for? Well, we're looking for this arc length, which is going to be z, which is part of that entire circle. And just like earlier, we of course can divide top and bottom of that ratio by 60. So we're looking at a ratio of 5/6, or the arc length is 5/6 of the entire circumference. That's going to be equal to z over this entire circumference of 2 pi x. All right, so just like earlier, let's go ahead and use cross products. If we go ahead and multiply the cross products here, we're going to say that 6z is going to be equal to, and then 5 times 2 is going to be 10. So we're looking at 10 pi x. Now dividing both sides by 6 here, we could say that z is going to be equal to 10 over 6 is really just 5 over 3. So we're looking at 5 over 3 pi x. This right here would be an expression that represents the arc length of that sector in terms of x if we don't know the radius. All right, so hopefully this video helped you feel a little bit more comfortable with understanding arc length and areas of sectors. Hopefully using these proportions or ratios can maybe help you understand it in maybe a different way, or just kind of help you wrap your heads around it a little better. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep with the great work that you're already doing.